Hello and welcome to lesson 12.2 in the Python tutorial series. My name is Steve, and today we're going to continue creating your own user-defined functions, and we're just going to build off what we did in lesson 12.1. In fact, on the right-hand side of the screen right here, you can see that I still have the code that we wrote in lesson 12.1, so if you didn't watch 12.1 and that code doesn't look familiar to you, you might want to take a look at lesson 12.1 because that's where we built that's where we built those user-defined functions. To continue what we're doing, we're going to start by working with the geometrical shape of a triangle. There's some calculations that we're going to do to determine the area of a triangle and the perimeter of a triangle, and then we'll write some more advanced user functions and finish it up with this lesson's challenge program. So to start off, we're going to write a function that will calculate the area of a triangle. The way you calculate the area of a triangle is simply to take the base of the triangle times the height of the triangle and divide it by 2. So it's 1/2 base times height is the calculation that you need to do. We're going to head over to our programming window here on the right. We're going to define a new function. It's going to be called area. You might be more specific and call it area of triangle, but that might be a little too much to type over and over. So we're going to call this function area, and we need 2 pieces of information in order for this to work. We need the base and the height. The main difference between this function and the other functions we've written thus far is this area function needs 2 parameters, not 1. We can't calculate the area of a triangle without knowing both the base and the height. So we denote that when we define our function by simply putting a comma between all the parameters we want. When we run this particular function, Python is going to be looking for 2 pieces of information, or 2 numbers, base and height. The next habit that you want to get into, always write a comment to describe what your function does. One of the worst habits you can get into as a programmer is forgetting to comment or not having any comments in your program. Even the smaller ones, get in the habit of writing comments. For this function right here, we are going to calculate the area of a triangle when given the base and height. And in order to do that, we're going to return base times height divided by 2. And just aesthetically, I always prefer to put parentheses around base and height here. Order of operations says that we'd get base times height divided by 2 anyway, so they're not necessary. But aesthetically, for me, to help organize what I'm trying to do, the parentheses help me think about what my function does. It works just like it does in regular math, so anything that you need to do to make the program more easy for you to look at, I definitely recommend doing. So we're going to take base times height, we're going to divide it by 2. That is going to be the area of a triangle. I'm going to go ahead and run this program now. And now that we've run the program, I have access to my area function. And so I'm going to take area, and let's say the base of the triangle is 10, and the height of the triangle is 8. That returns 40.0, which is 10 times 8, which is 80, divided by 2. So our area function is working correctly. We can see that returned as a floating point number. That's because we used the single division way back in probably lesson 2 or 3. Remember, if you want it to return an integer, you use 2 slashes. When we do that, area 10, 8, we would get an integer. But we're going to leave this as standard division and return a float because it is entirely possible that we're going to get some decimal numbers. If we did area 5 and 7, see, we're going to get 17.5, and if we do integer division, we won't have the option to get that. So real simply, that is a function that calculates the area of a triangle. Another thing to kind of keep in mind is you're not limited to just integers as arguments. If I were to take the area of something like 10 and 7.45, I could calculate that just as easily. So your arguments don't necessarily have to be integers. Now, one thing that will kind of happen sometimes, this function takes two parameters. Python is going to expect to find two parameters every time it's run. So if I were to take the area of 4, I'm going to get a type error. It says area takes exactly two arguments, one given. You might see this error fairly commonly when you're writing programs, and particularly when we move into classes, you'll see this more and more often. But if you see this type error and it's saying that area takes exactly two arguments, one given, what it's saying here is you've provided one argument when you called the function, and it is expecting exactly two arguments. Likewise, if I were to run area 4, 5, and 6, I'd get the same type error, but now it's telling me that you've provided 3 arguments and we only needed 2 positional arguments. There are ways to write functions that can take a variable number of arguments. We're not going to worry about that just yet. Okay, I'm going to clear my screen over there on the left and write one more triangle-centered function just to make sure everyone's got the hang of this. I want to write a function that's going to calculate the perimeter of a triangle. In order to calculate a perimeter, I just need to add the length of each of the 3 sides. So I'm going to define a new function with the def, the define keyword. I'm going to call this function perimeter. And in order for it to function, I need to know the length of each of the 3 sides. So my parameters are going to be side 1, side 2, and side 3. I'm going to write my comment to let everyone know what this function does, and it's going to calculate the perimeter of a triangle when given the length of each of the 3 sides. My return statement is going to add side 1, side 2, and side 3 together. And let's execute this and make sure that it runs properly. So I'm going to run perimeter of a triangle with the lengths 4, 5, and 6 as the sides. And that's going to return a value of 15. 4 plus 5 plus 6 is 15. I'm going to try this with floating point numbers and say I'm going to add 4.25, 9.125, and 7 as my lengths. I get 20.375, which is correct. So my perimeter function is also working correctly. Just like with the area function, this function is going to want 3 arguments provided every time it's run. So if I were to run perimeter 4, 5, I get the type error 2 arguments given when it's expecting 3. And if I ran it with too many, 4, 5, 6, 7, and 8, I'm going to get the same type error because I provided 5 arguments when it's only looking for 3. Just like with area, what's happening is when I run these arguments, perimeter, let's run a correct perimeter function call for this example. So let's get 4, 5, and 6 back up. What's happening is perimeter is being run. It's checking to see if we have a function called perimeter, in which case we do. Side 1 is taking on a value of 4. Side 2 is taking on a value of 5. And side 3 is taking on a value of 6. So when this function is run one time, we get 4, 5, and 6, and these work just like variables do. So it's taking 4 plus 5 plus 6 and returning that number. If we were to reverse these letters or change them up, or these numbers and change them up and do 5, 6, and 4, we're going to get the same answer. But functionally what's happening is side 1 is now a value of 5, side 2 is now a value of 6, and side 3 is now a value of 4. So the arguments you provide will be passed to the function in the same order when they're called as they are set up as parameters when you defined the function. One important thing to remember about a return statement is a return statement will break the running of your function. What that means is once your function encounters a return statement, nothing else in the function matters. It will return a value and forget the rest exists. So let's write a function, we'll call it return then print. And return then print is going to take one argument, num. And what we're going to do is put our comment in here. This provides an example of return statements breaking a function. When I say breaking a function, I mean it stops running, not that it ceases to work anymore. So let's print num, print num plus 1, print num plus 2. Then we're going to return num plus 3. Remember that the return statement doesn't use parentheses. And one interesting thing happens. You can see after I run my print statement, I hit enter, and my cursor stays indented 4 spaces. When I hit enter after the return statement, my cursor goes back to the left side of the screen. That's because Python knows that nothing that comes after that return statement can be executed. So that's if you hit enter and your cursor ends up not where you think it's going to be, that's an indication that maybe something's wrong. But let's continue this. Let's go print num plus 4, print num plus 5. Let's run this program. And I'm going to return then print, passing an argument of 1. Now what's going to happen is it will come over here and it should print 1, 2, 3. Then it's going to execute this return statement right here. Well, it's going to return the number 4 because 1 plus 3 is 4. And then you've got these 2 print statements that occur after the return statement. When I execute run then print, I get 1, 2, 3, and 4. These 2 lines are never encountered by the program. In fact, I could write total gibberish in here. I could misspell something. I could call print num plus 6. Now normally if I were to do that, if I were to type prnti num plus 6 over here, I get a name error. Printy is not defined. However, when I run return then print with the number 1, I get 1, 2, 3, 4. I don't even encounter this error because Python is not seeing any of these 3 statements. Once it hits that return statement, your function is over. This is why you can have multiple return statements in a function. If you're using like an if, a bunch of if checks, and you want it to return certain values if your program meets a certain condition. But once it finds one return statement, it's not going to execute any more of your function. In fact, if I were to say x equals return then print 1, it's still going to print 1, 2, and 3 because it goes through and it says, okay, x equals return then print 1, so I'm going to print 1, print 2, print 3, and then it's going to return a value num plus 3. So it's going to return a value of 4, but instead of just displaying that on the screen, it's going to assign a value of 4 to x. And I can see that if I hit x, x equals 4, and that's because it took on the return value of my function. But everything after that kind of gets short-circuited and not encountered, not executed. It doesn't matter what kind of errors you have. It doesn't matter if you have type errors or syntax errors or any of that stuff, because Python never executes lines that it encounters after a return statement. The return statement will end your function. Okay, so we're just about finished up talking about user-defined functions. One of the common questions I get from my beginning programming students in class is why would I write a function for this kind of stuff? If I wanted the area of, say, a triangle, why wouldn't I just create a variable called base, a variable called height, do the calculations, and then print the area, or do whatever I want with the area? Why would I write this as a function? Well, the true value of functions comes in the fact that you can run the same blocks of code dozens, hundreds, thousands of times without having to recode it every single time. Without a function, I could take the area of a single triangle. I could set a base and a height and calculate one triangle, but what if I had 50 triangles that I was trying to calculate the area for? It would be much easier to have those calculations pre-stored so I could run the function as many times as I want and get as many different answers as I want. Functions don't need to have parameters built into them as either. You can have a function that you create that takes no parameters. Let's hypothetically make a function here, and we're going to call this function number input. And when I set the parameters, I'm just going to have the open parentheses and close parentheses. That's my instruction to Python that, hey, this function does not require any arguments when it's run. And I'm going to do, this will ask the user to input two numbers, then return a sum. Excuse me. And so I'm going to have num1 equal input, enter a number. And then num2 is going to equal input, enter another number. And then I want to return num1 plus num2. Another way that you can do this is sometimes it gets more difficult for me to pay attention to my programs when I'm doing mathematical calculations in my return statement. One thing that sometimes helps me out when I'm trying to find these is to do all my calculations, then return a final variable. So I can return num1 plus num2 here. Or I can create another variable. I'm going to call this variable final num. And I'm going to set that equal to num1 plus num2. And then I'm going to return final num. Now, from a programming standpoint, this second version is less correct. It would be more effective to return num1 plus num2, but one thing that you got to get used to, or something that the advice I give to my students, do what makes sense for you. If you're writing a program, write something that's going to make sense to you. It doesn't matter if it's super technically correct. You can go back and fix it later. But while you're learning programming, you want to make sure that you understand why your program is working the way it's working, and you don't need to get bogged down in what's the most efficient, what's technically correct. Either one of these would be fine. So I'm going to leave this number input, final num gets calculated here, and then we're going to return final num. So this function, when we run it, will ask the user to enter two numbers and then add those two together. So let's go ahead and run this program. We now have access to number input. One common mistake that beginning programmers sometimes make, particularly with functions that take no parameters, if I want to run this number input, it doesn't need any arguments. But if I just type number input, I get function input at and then this memory address. If I don't have the parentheses on the end of my function call, whether it needs arguments or not, this is simply going to return to let me know that at this memory address, there's a function called number input and where it's at. If I want to run this, or if I want to make a function call on the number input function, even though it takes no arguments, I still need the open and close parentheses. That is a function call with no arguments. Now I'm going to enter a number, 5. I'm going to enter another number, 9. And it's going to return 59. The reason it returns 59 is even though those input statements are in a function, they're still taking input as a string. If I want these numbers to be treated as numbers, just like we did in Guess the Number, I need my input statements to be part of an integer function call. So I'm going to call the function integer. The function integer is instructed to take the argument and convert it to an integer. And in this case, my argument is an input function where the user enters a number. So just like in Guess the Number, I'm going to enter 5 here, convert it to an integer. I'm going to enter 9 here, convert it to an integer, and then try and add those two things together. So let's try that again. Number input, function call, enter number 5, enter another number, 9, and I get 14. So let's go to our programming window over here, and let's run number input as part of our program. And I want to store the return value of number input in a variable. That is, x is going to be equal to the sum of the two numbers that I enter when number input is run. I'm then going to create a variable y with number input and a variable z with number input. And then finally, I'm going to print x plus y plus z. What I'm doing here, the example that I'm providing you here, number input has these input statements and all this stuff, but I only have to write the input statements once, I only have to convert them to integers once, I only have to sum them once. This entire block of code can be repeated as many times as I want. So instead of rewriting this block of code 3 times, this highlighted block of code here, I can write it once and call it 3 times, storing the values in x, y, and z, and then I can take the sum of all the numbers that I inputted. So let's go ahead and run that. It says enter a number 5, enter another number 9. It's going to store that value in x, and it's going to run number input again. In this case, I'm going to enter a number 2, enter a number 4. The function is now done running. It returns final number and stores that in the variable y, and then enter my last two numbers, 10 and 3, and it's going to print 33, x plus y plus z. X had a value of 14, y had a value of 6, and z had a value of 13. So the true power of functions is the ability to write blocks of code once and then run them dozens of times. If you have an error, if you made a simple mistake, like you forgot to convert something to an integer, instead of having to fix 3 separate blocks of code that you hard programmed into your program, you only have to fix the function once, and it drastically cuts down on the amount of time it takes to fix bugs when you make simple mistakes. So that should be enough to get you started on user-defined functions. Let's talk real quick about this week's challenge program and move on from there. Okay, so we're moving on to the challenge program for this week, and really this is 2 programs or 2 functions wrapped up into one. The first one is going to be a random number generator, but the user will input the maximum and minimum number or the range to generate the number in, and then your function will generate the random number between those two and return the results. So I'm over here in my programming window, and you can see that I've already run my program, which is hidden from view, and I called mine generator. Generator prompts the user enter the minimum number to generate. So let's say we want a number between 7 and the maximum number to generate between 7 and 89. It says I'm going to generate a random number between 7 and 89, and that number was 51. If I ran that program again with the same data input into it, 7 and 89, I get a different number. This time I got a 14. And I can run this with any parameters or any arguments that I want. So generator between a number between 100 and 987, I get the number 317. So the first part of your challenge program is to simply write this random number generator. I can tell you right now that the function that I wrote doesn't take any parameters. Both of these, this is true for both of the functions I'm going to have you write, they don't take any parameters because they rely on user input. So the first program is just a random number generator where the user selects the range prior to the random number being generated, and then we return that random number. The second challenge program I think is a little bit more interesting and a little bit more utility. And this is good for anybody who's, if you've ever played a board game, Sometimes you run out of dice. You don't have dice. Now, most board games use like 6-sided die, but if you're into some of the more thematic board games, there are 4-sided die, 10-sided die, 12, 20. I mean, there's all kinds of different die to use. So the second part of your challenge program is to write a random dice roller program. I named mine dice. So when I call dice, it prints a little menu that says dice generator, and it says choose the type of dice to roll. 4-sided, 6-sided, 10, 12, or 20. So I'm going to roll a 6-sided die. So I'm going to enter 2 off my menu, and it says you roll a 6-sided dice, and the number is 4. I'm going to run this again. I'm going to choose another 6-sided dice. This time I rolled a 6. I'm going to run this function again, and this time I'm going to choose a 12-sided die, and I rolled a 10 on my 12-sided die. So by running this function, it's running a full dice generator block of code that prints a menu, allows the user to select what type of dice they want to roll, and then returns that value. Because I'm using a return statement, I can set the value to a variable. I can say that random roll equals dice. Now I've got a variable now called random roll, and it's going to get a value, but I don't know if it's a 1d4, whether it's a 1d20. I don't know what type of dice it's going to be because the user hasn't inputted that information yet. So I'm going to, as a user, I'm going to input, I want a 20-sided dice roll. So I select number 5, and it says you roll a d20, and you got a 2. But the nice thing about this is random roll has a value of 2 stored in it. So I can store the results of my dice rolls because they're being returned by my function. So that right there is your challenge program for this week, to see if you understood what we're talking about and see if you can make a program that matches the output that I have on the screen. Remember, there's 2 parts to it: writing a random number generator where the user selects the range, and then writing a random dice generator where the user gets to select the dice that they're going to roll, and then the program rolls the appropriate dice and returns the number. As always, if you have any questions about this week's challenge program, anything you've seen in this or previous lessons, please go ahead and leave those in the comments, and I will do my best to answer them as best I can. The ultimate goal is to make you a better programmer and have you understand not only what you're doing, but why what you're doing works. Thank you so much for watching, and have a great day.